Okay, we're at the swiping station. So there, from left to right is A, B, C, D. And I'm gonna put them down and I'm gonna swipe. See how fast they evaporate. Here is A and C again. So you can see them. One more time for A and C. And I think it's obvious between B and D which one is taking the longest. Okay, here we are going to boil our three substances, and we have A, B, and D. C is not being used in this one. And we'll turn our heat on to get them to heat up. And then we will not only pay attention to how fast they boil, but we will also record their temperatures using the thermometer here when it comes time. All right, we're starting to see that A is now boiling, and we'll record temperature of A. A is boiling, looks like about 56 degrees. About 56, 57 is holding at between there, about 57 degrees. So A boiled first, about 57 degrees. We'll remove A. Continue to heat B and D. And now we're seeing B begin to boil. It's not quite there yet. And now that B is fully boiling, we see that B is boiling, and we are at about Looks like about 79 degrees. See if we get to 80 or not. Yeah, about 80 degrees. So we see B boiling about 80 degrees Celsius. Which that leaves D, and our lab says we do not have to see the last one boil. We could just record it that this one boiled hotter than the other ones. So we'll stop the video now knowing that D must boil above 80 degrees, or well above 80 degrees. In fact, we can take a temperature before we leave here, and let's see how hot it is at this point in time. It also seems for D to be taking a lot longer for it to absorb this energy than the other ones. And we are well above 90 degrees Celsius right now, and D is not yet boiled. But it is getting close to it. So we'll stop the video here. So well above 90 degrees with D beginning to boil. Okay, here's our test of a charged rod that needs to be charged up. We do that by just rubbing it against a piece of fabric. I'm using the inside of my sweater. And now we've created an imbalance of electrons on here. And we're gonna turn on first liquid A. And we see that as it comes close to liquid A, it definitely does create some sort of bending or disturbance of that beam. We go over to liquid B, and we will again charge up the rod, turn on liquid B, and we definitely see an imbalance or a pull on liquid B. We'll move over to liquid C. And with liquid C, we see no effect. It sits here and does nothing. And then finally we go to liquid D. And you can definitely again see an effect of how it will bend. How it can bend that to the point where I can get it to even come out of the container. We can bend that stream. When we're done with lab, we will replenish the burettes. Okay, here's our test of how much something beads up or domes up with drops. So there's 1, 2, 3, 4, 5 drops for A. See it way over here. Here's 1, 2, 3, 4, 5 drops for B. Here is 1, 2, 3, 4, 5 drops for C. And finally, here is 1, 2, 3, 4, 5 drops for D. So you can see how much they bubble up versus how far they spread out. Again, we are left to right, A, B, C, and D. Okay, in this video, we're gonna look at the solubility of sodium chloride in our 3 liquids. So we'll start with A, and looking at A, we have dissolved sodium chloride in here. And if we look, I cannot see the salt anywhere in here, which means it has dissolved. In B, I come up and look at it. Also in B, I am looking, and I cannot see the sodium chloride, so it has dissolved. In C, if I look, I can see it. It's hard to see on the video, but at the bottom of there, when you're live, you can actually see salt particles still sitting in the bottom of this container. Maybe if I turn it sideways, there you can see it now. See the white little in the bottom corner there? Make it move. You can see the white salt that's inside of here. So C did not dissolve it. And D again, we come back and we cannot see the salt. So this one has dissolved it. So our results tell us that A, B were able to dissolve the salt, C was not, and D was able to dissolve the salt. Okay, in this video we're going to test for the solubility of oil inside our 4 liquids, and we're going to start with A. And looking at A, it looks like a clear liquid. I don't see 2 layers of the oil. If I shake it up, trying to see if I can get some cloudiness, maybe a little bit. You kind of see some bubbling at the top there, but for the most part, kind of tough to tell if A has got 2 layers of the oil or not in it. Taking a look at B, we see some cloudiness at the bottom already. If I kind of tilt that over, something's going on down there. You kind of can see it different. A little bit hard to see in the video, but when I shake it up, it definitely gets cloudy. So that means there's something going on. Maybe we'll let B sit and come back to it and see if it starts to separate out into layers. Looking at C, from first glance, it looks like it's very clear. I cannot see any difference. You can almost look through it. Shake that up, and yeah, it goes right back to being clear. So C definitely is able to dissolve the oil. And we go to D, and you can see the oil sitting on top of D. Right there, the big bubbles of it, and I shake that up, and instantly goes cloudy, and very quickly starts to layer back out. So D definitely does not like the oil. So D, we would say for sure the oil is not soluble in that. For C, we could say for sure it was soluble. Let's peek at B again. And there's that cloudiness, but I am seeing a difference. Maybe not quite as obvious on the video, but I am seeing a difference where the top is starting to lighten up and clear up again, and the bottom almost looks oily. To me, it's hard to show the bottom in the video, but the bottom is kind of creating another layer. So I would put B to the same as D, saying that it did not dissolve the oil very well. And then go back to A again. And again, A, kind of inconclusive what was going on with A. Maybe it dissolved kind of it a little bit, maybe not really sure.